There is a graveyard in German aviation history that nobody planned for. Between 1961 and 1989, the West German Air Force lost 292 pilots flying a single aircraft. Not in combat, not in war, in peacetime training missions over the forests and farmlands of their own country. One pilot dead every 5 weeks on average for nearly 3 decades. The aircraft responsible was called the F-104 Starfighter, and the Germans gave it a nickname that tells you everything you need to know: the Witwenmacher, the Widowmaker. To understand how this happened, you first need to understand what the F-104 actually was, and more importantly, what it was never designed to be. Lockheed engineer Kelly Johnson built the Starfighter in the early 1950s based on a simple and brutal philosophy. He had spoken with American fighter pilots during the Korean War, and they told him the same thing over and over. They wanted something faster, not safer, not more forgiving. Faster. Johnson delivered. The F-104 was essentially a missile with a cockpit bolted onto it. It had the smallest wings ever fitted to a production fighter aircraft, razor-thin slabs of aluminum so sharp that ground crews had to put protective covers on the leading edges to avoid lacerating themselves during maintenance. The wings measured just over 21 feet across. The fuselage was 54 feet long. The geometry alone tells you this machine was built for one environment: high altitude, high speed, and nothing else. The United States Air Force used the Starfighter primarily as an interceptor. Its job was to climb fast, fly at Mach 2, and engage Soviet bombers at extreme altitude. In that specific role, the aircraft performed adequately. American pilots flew it carefully within its limits, in the conditions it was designed for. The U.S. lost far fewer proportionally, and when American interest in the jet faded, they moved on relatively quickly. Then came the sale that changed everything. In 1958 and 1959, West Germany was rebuilding its military under NATO and desperately needed a modern multi-role aircraft. The Starfighter won the contract in circumstances that were later described as involving bribes, political pressure, and one of the most controversial arms deals in post-war European history. Lockheed paid millions in illegal commissions across multiple European governments to secure F-104 sales. In Germany, the scandal eventually brought down a defense minister, but that came later. In the late 1950s, the jets arrived, and the Luftwaffe began training a generation of pilots to fly an aircraft that had been quietly, fundamentally modified to do something it was never engineered for. The Germans needed a low-altitude strike aircraft, a jet that could fly fast and low through European terrain, deliver nuclear or conventional weapons against Soviet armor, and return. The F-104G, the G standing for Germany, was adapted accordingly. More weight was added, new avionics, heavier weapon systems, additional fuel capacity. The airframe that Johnson had designed to be light, fast, and unforgiving at altitude was now being asked to operate in the dense air close to the ground, heavily loaded, in the notoriously unpredictable weather of Central Europe. The physics of what this meant were merciless. The Starfighter's tiny wings generated lift, but they required speed to do it. Lots of speed. The aircraft's stall speed, the minimum velocity needed to maintain controlled flight, was dangerously high compared to contemporary fighters. At altitude, this was manageable. Close to the ground, it was a potential death sentence. Any loss of engine power, any mechanical failure, any moment of distraction that allowed the aircraft to slow below its critical threshold meant the jet stopped flying almost immediately. It did not glide. It did not offer the pilot time to think. It dropped, vertically, fast. German instructors began calling it the Erdnagel, the ground spike. The Americans had already nicknamed it the lawn dart. Both names describe the same geometry of death. Now here is where the engineering became genuinely fatal for the men flying it. Every aircraft has an ejection seat. It is the last line of survival when everything else has failed. The system installed in the early German F-104s was the Stanley C-1 ejection seat, and it fired downward. Look at the diagram of the system and let the logic sink in. The seat used explosive charges to propel the pilot out through the bottom of the aircraft. The reasoning was aerodynamic. At the extreme speeds the jet was designed to fly, ejecting upward risked the pilot being struck by the tail. The engineers solved one problem and created another one that was far more dangerous in practice. Ejecting downward out of an aircraft works when you have altitude. If you are at 40,000 feet and your engine fails, you have time. The seat fires downward, the aircraft continues forward and upward momentarily. The parachute deploys, you float to safety. The geometry is survivable. But the German Luftwaffe was flying this aircraft at low altitude. Strike missions required flying at treetop height, sometimes below 500 feet, sometimes below 200 feet. When an engine flamed out at 300 feet above German farmland, the pilot had perhaps 1 second before impact. He reached for the ejection handle. The seat fired downward, directly into the ground. At those altitudes with a downward firing system, ejection was not an escape mechanism. It was a different method of dying. The numbers reflect this with horrible precision. Of the 292 German pilots killed in F-104 accidents, a substantial portion died in scenarios where ejection either could not be initiated in time or where the ejection system itself was the wrong tool for the altitude. Pilots who survived crashes later described the psychological weight of knowing that pulling the handle at low altitude was not a guaranteed salvation. It was a calculation under extreme stress, fractions of a second, with the ground filling the canopy. Germany eventually replaced the Stanley C-1 with an upward-firing Martin Baker ejection seat, a modification that came years into the aircraft's operational life. The Martin Baker 00 seat, capable of ejecting a pilot safely at zero altitude and zero forward speed, was available technology. It was used in other aircraft. The decision to equip the F-104G with the downward firing system initially was a combination of aerodynamic orthodoxy and procurement decisions made before the true low-altitude mission profile was fully understood. That decision cost lives that could have been saved. But the ejection seat was only one part of the machine's appetite for its pilots. The F-104 had additional characteristics that made it uniquely unforgiving in German hands. The aircraft had what engineers call adverse yaw, combined with a powerful tendency to depart controlled flight under certain conditions. At high angles of attack, particularly during aggressive maneuvering close to the ground, the nose could pitch up violently and the aircraft would enter a spin from which recovery was almost impossible at low altitude. German pilots flying tactical strike profiles were regularly operating in exactly this flight regime. The T-tail configuration, where the horizontal stabilizer sits at the top of the vertical tail, created a phenomenon called deep stall. In a deep stall, the horizontal stabilizer sits in the disturbed airflow behind the wings, rendering the elevator almost useless. Recovery inputs from the pilot produced no meaningful response. The jet continued its trajectory without apology. The weather over Central Europe compounded everything. Germany is not the Mojave Desert, where American test pilots refined the starfighter. Germany has low cloud, rain, fog, rapidly changing visibility, and terrain that rises suddenly. Pilots flying low-level navigation routes at high speed in marginal weather had very little margin for any mechanical anomaly. The German Luftwaffe also had an extremely aggressive training program, pushing pilots through a demanding syllabus because NATO required operational readiness. Young pilots with relatively few hours were flying one of the most demanding aircraft ever built in one of the worst possible environments for its design parameters. Between 1965 and 1970, the crash rate was at its most severe. Aircraft were falling at a rate that would be considered a national emergency in any context outside of actual warfare. The German press began covering every accident. Families of pilots spoke publicly. Politicians demanded answers. The Luftwaffe defended the aircraft and defended the training program, arguing that the losses were acceptable given the strategic necessity. The widows of the pilots who had died might have offered a different definition of acceptable. What is historically important to understand is that this was not inevitable. The Hawker Hunter, the Mirage 3, the English Electric Lightning, all were demanding aircraft of the same era, all capable, all fast, none with a casualty record remotely comparable to the German F-104 program. The difference was mission profile, modification weight, weather environment, and the ejection seat that fired in the wrong direction when the worst happened at the worst altitude. When the last German F-104 was retired in 1987, the full accounting was done. 916 aircraft had been delivered across all NATO operators. Germany alone lost 292 pilots and 298 aircraft. The ratio of losses to flight hours was unlike anything seen in peacetime aviation before or since in a Western military context. The Starfighter's designers had built a magnificent machine for a specific purpose. The politicians and procurement officials had purchased it for a different purpose, and 292 German men had died in the space between what the aircraft was and what it was asked to be. Kelly Johnson's original philosophy, give the pilots speed and nothing else, was honest in its ruthlessness. The jet he designed was a precision instrument for a precise task. What happened in Germany was not a failure of engineering in isolation. It was the consequence of forcing an unforgiving machine into a role it could not tolerate, in terrain and weather it was never meant to see, with an escape system oriented in the wrong direction for the altitudes where men most needed to escape. The Witwenmacher, the Widowmaker, the Erdnagel, the Lawn Dart. 4 names in 2 languages for the same truth. When a machine is designed to do one thing and asked to do another, it does not adapt. It does not compromise. It simply continues to do exactly what its physics demand. The 292 pilots of the German Luftwaffe did not die because they lacked courage or skill. They died because they were handed an instrument of precision aerodynamics and asked to use it as a hammer, close to the ground, in the rain, with a seat that fired downward into the earth they were trying so desperately not to hit.